this video, we're going to figure out how to identify forces on objects. So we've previously seen that a force is an interaction between two objects. Because forces are interactions between two objects, forces always come in pairs. There's always a force on each of the two objects that are in the interaction. All right, so there are two main types of forces. There are contact interactions that produce forces, and there are also non-contact interactions. The first one we're going to talk about is contact interactions. And like the name suggests, these contact interactions happen when two objects are touching. If two objects are touching, they're in contact, and so you get a contact interaction, which results in a force. An example of this is, let's say you have a wall and you push your hand up against the wall. When you do that, your hand exerts a force on the wall to the right in this picture, and the wall is pushing back on your hand to the left. So these forces are what we call equal and opposite. They're the same size, but they're in opposite directions. And anytime two things are touching each other, this is what's going to happen. You're going to get a force from object A on object B, and then another force from object B onto object A, and they'll be in opposite directions but the same size. Okay, so that's the first kind of interaction, contact interactions, and then we have non-contact interactions, and there are actually three types of non-contact interactions. The first one we're going to talk about are gravitational interactions. These ones we're familiar with because we all live here on the planet Earth. And gravitational interactions happen when things are on Earth or nearby Earth. They also happen when they're on other planets, moons, around stars, really, really big things, basically. If something is by something that's really, really big and massive, there'll be some gravitational interactions. So here is an example of a gravitational interaction. Let's say you hold a ball above the ground. And if you let go of that ball is going to start falling towards the ground. The reason why it does that is because there is a force, a gravitational force from the earth pulling down on that ball. So I've labeled this an F for force and then a G for gravity, and then earth on a ball because it's the earth pulling down on the ball. But remember how I said all of these forces, because they're interactions between two objects, have come in pairs? Well, there's another force here, but it's actually on the ground from the ball. So the ground is actually being pulled up towards the ball. The ground, like Earth, right, is so big and so massive, it doesn't move like the ball does. So we see the ball fall to the earth instead of the earth going up towards the ball. Okay, another example of this is, let's say we have the earth again, and we also have the moon. The moon and the earth are big, massive things out in space, and they're relatively nearby each other for things being out in space. And the earth is pulling on the moon with gravity, and the moon is pulling on the earth with gravity. And those two forces are equal and opposite. This force on the moon from the earth is what keeps the moon in orbit around the earth. And the force on the earth from the moon is what helps cause things like our tides on this planet. So both of these forces, we definitely feel the effects from them. All right. The next kind of non-contact interaction are electrical interactions. And these happen with charged objects. So anything that's positively charged or negatively charged, we're going to get electric interaction. A good example of this is if you take a balloon and you rub it in somebody's hair and then you kind of pull the balloon and the hair apart, you can see that the hair will want to stick to the balloon. It kind of reaches out towards the balloon. And this is because of an electric force. So let's say the balloon is negatively charged and the hair ends up being positively charged. And that happens after you rub those two things together. They get charged up by friction. And because they're opposite charges, they attract each other. So the hair feels a force, an electrical force from the balloon, and the balloon feels an electrical force from the hair. And again, these are going to be equal and opposite forces. All right. The third kind of non-contact interaction is a magnetic interaction. And this happens with magnets, you guessed it. Yeah, so magnets, but it also happens with things like currents. So this is moving charges. And the details of that are a little bit more complicated. But let's imagine that we have two magnets, and magnets always have a north pole and a south pole. You can't ever separate those two things. Every magnet, no matter how big or small it is, will always have a north and a south pole. And let's say we take two south poles and we push them towards each other. They're going to want to actually repel. They don't like each other. They don't have to touch, and they start pushing away. And that is a magnetic interaction. All right. So now that we know the different kinds of interactions, we might want to ask ourselves, how do we know what forces are on an object? What kind of interactions are happening? Well, I like to use a really simple tool called a system schema to help us figure this out. So the best way to teach this is to give an example. Let's imagine we have a kid who is playing in a tree. They're climbing in a tree and they're hanging on one of the branches. All right, so to make a system schema, the first thing we do is we just list the objects. So in this case, we've kind of got three objects that I see. We have the kid, and we have the tree, and we have the earth. So those are our three objects. The next step we do is we're going to draw something called interaction links. So interaction links, we can have one link for each type of interaction between objects if that interaction is happening, right? So we're going to start with the gravitational interactions. I like to do this one because most of the things we're thinking about are going to be on the earth or nearby the earth or something like that. So anything that is near the earth is going to have a gravitational interaction with the earth. So I'm going to draw a little interaction link. It's like a line with two arrows that go and point at the earth and point at the kid. And those two arrows on the ends show me that there's going to be a force on the kid. There's also going to be a force on the earth. And same for the tree, right? There's going to be a force on the earth and there's going to be a force on the tree because of that gravitational interaction. All right. So then I think about my other non-contact interactions. The next one would be, let's say, magnetic. Are there any magnets here? No. So there's not going to be any magnetic interactions. The next one is electrical. Are there any charged things here? No, there's no charged things. So there's no electrical interactions. Then the last thing, those are all my non-contact interactions. The last things would be contact interactions. So this is just what's touching. Are there any objects touching here? So yeah, there's definitely some objects touching. The tree is touching the earth, so that's a contact interaction. And the kid is holding on to that tree. So that's another contact interaction. And again, I'm just drawing those interaction links that have the arrows going to both sides. And that's showing me that there's going to be a contact with the tree on the kid. That's going to have a force, and there's going to be a force on the tree from the kid. All right, so now we can look at our system schema, and we've accounted for all of the forces on these objects. We can see that the kid has two arrows pointing at it. It has a gravitational pull from the earth, and there's a contact from the tree. So the kid's going to have just two forces on him. And the tree is going to have three, right? It has a contact from the ground or the earth. It has a gravitational pull from the earth, and it has a contact from the kid. So that's it. Pretty simple there. The one thing that I don't know if I mentioned, but I'm going to mention it again, is just in case, is that we can only have one arrow for each kind. So like even if the kid was holding on with two hands, we would really kind of just think about that as one interaction, unless we want to really complicate our model. Okay, now let's do another example because I like examples. Let's say this one we use some magnets. I have this really cool demo that I like to do where I have a superconductor and I can float a magnet on top of it. So let's say we have a superconductor sitting on the floor, and if I cool off that superconductor, it's really cool. It turns into like this perfect magnet, and I can float another magnet directly above it. So that's what this picture is right here. We've just got we've got a blue magnet floating on top of this black superconductor. All right, so I want to know, what are the forces on my objects here? So I'm going to draw a system schema, starting again by just listing the objects. I've got the superconductor, I have the magnet, and then I have the Earth. And now I'll draw some interaction links. So I'm going to start with the same one I did before. I'm going to start with gravitational. So are there any gravitational forces or interactions going on here? Yeah, there are, because there's the Earth. So both the superconductor and the magnet have interactions with the Earth via gravity. And now I think about magnetic. In this case, there is a magnetic interaction. The superconductor and the magnet are both magnets, so they are going to have a magnetic interaction. And I'll draw a little M to represent magnetic there. And then electrical, no electrical interactions happening here. These two things aren't charged. They're magnets, but they aren't charged. They don't have positive and negative. And then the last thing is contact interactions. Well, the magnet's not actually contacting anything, but the superconductor is contacting the Earth. It's sitting on the ground. So I'll draw a little contact interaction there. And so now I can see the superconductor has three interactions on it, so it'll have three forces, and the magnet has two. So this helps us just identify what kinds of forces are on objects. And we'll use this later to help us figure out how forces change the motion of objects.